Right now, pick up a pen, don't think about it, just do it. 9 times out of 10, it just landed in the same hand it always does. You didn't choose that, you never chose that. Somewhere around age 2, your hand decided for you, and it has never once asked permission since. Here's the part that should bother you. Across every culture, every continent, every century of recorded history, roughly 9 out of 10 humans favor that exact same hand. Not 6 out of 10, not 7, 9. That is not a coin flip, that is not chance. A coin flip would split close to 50-50, the way it does in literally every other species on this planet capable of holding something. Chimpanzees don't do this. Gorillas don't do this. Not one other primate, anywhere in the entire animal kingdom, shows a population-wide preference like this. Just you, just humans, so what happened? Go back far enough, and the chimpanzee branch of the family tree split from yours somewhere between 5 and 7 million years ago. That's your closest living relative. If handedness were just some random genetic accident, you'd expect chimps to show at least a little of the same pattern. They don't. Individual chimps might favor one hand, sure, the same way an individual human might favor one foot for kicking a ball. But as a population, chimpanzees split close to even. No group-wide lean either direction. Gorillas, orangutans, bonobos, same story. Whatever pushed humans this far off balance happened only on your branch of the tree, sometime after that split, and it happened hard. For decades, scientists genuinely could not answer that question, and not because nobody was trying. Researchers have tested theory after theory. Maybe it's about language, since the left side of the brain controls your right hand and also happens to handle most speech, so the two traits might have evolved bundled together. Maybe it's about tool use, since early humans needed a steady, dominant hand to chip stone into blades without slicing off a finger. Maybe it's about teaching, since copying someone else's exact hand movements is far easier if both of you are already wired to favor the same side. Every theory sounded reasonable. Every theory partly explained the picture. None of them explained why humans, specifically, ended up so extreme compared to every other primate alive. And this isn't some brand new trait that showed up alongside writing or farming or anything recent. Go back 300,000 years, well before a single modern human walked the earth, and you'll find it already there. Neanderthals left behind something strange on their own teeth. Tiny diagonal scratches, the kind you get from gripping food in your mouth and slicing toward it with a stone tool held in one hand. Anthropologist Natalie Uomini studied those scratches across dozens of skulls and found the same pattern again and again. Mostly right-handed. The same bias in a species that went extinct tens of thousands of years before a single modern human was born. Whatever caused this, it didn't start with you. It didn't even start with your species. So the mystery sat there for decades, unsolved, annoying. The kind of question scientists quietly file away because every angle they try just runs into a wall. Then, in 2026, a team at the University of Oxford tried something nobody had fully done before. Anthropologist Thomas Püschel, along with researcher Rachel Hurwitz and Professor Chris Venditti from the University of Reading, pulled together handedness data from over 2,000 individual monkeys and apes, spanning 41 different primate species. That alone took years. Then they built something called a phylogenetic comparative model, which sounds complicated but really just means a kind of evolutionary simulation. Feed it a family tree of related species, feed it a trait you're curious about, and it estimates how that trait likely changed, branch by branch, across millions of years of shared ancestry. Once the model was built, the team threw every existing theory into it at once, one after another, and waited to see which ones actually survived contact with the data. Diet, habitat, body size, social structure, tool use. One by one, the model tested them all, and humans broke the model completely. No matter which factor the researchers tried, humans sat off to the side, a statistical outlier, a species that simply didn't fit any known pattern among primates. For a moment, it looked like the mystery was about to stay a mystery. Here's the twist. The researchers added 2 more variables into the mix almost as an afterthought: the size of the brain, and the ratio between arm length and leg length, which is just a fancy way scientists measure how committed a species is to walking upright on 2 legs instead of 4. The instant those 2 factors went into the model, the human anomaly disappeared. Gone, just like that. Once you account for walking upright and having an unusually large brain, human right-handedness stops looking impossible. It starts looking exactly like what evolution would predict. Sit with that for a second. The answer to one of the strangest open questions in human evolution turned out to be hiding behind the two most obvious things about being human. But here's where it gets even better, because the story isn't just big brain, right hand. It happened in two separate acts, millions of years apart. Act 1 starts with walking. Long before any human ancestor had anything close to a modern brain, something else changed first. Posture. Picture an early hominin, something like Australopithecus, 4 million years ago, rising onto two legs for the first time in its lineage's history. Its hands, which had spent millions of years gripping branches and supporting its own body weight in the trees, were suddenly completely free. For the first time ever, those hands had nothing left to do but specialize. And specializing meant picking a side. One hand for fine, controlled, skillful work. The other hand for steadying, holding, supporting. That split didn't need a big brain to begin. It just needed two free hands, a body standing upright on the ground instead of swinging through branches, and a reason to use those hands differently. Act 2 comes later, and it's where the brain finally enters the story. As hominin brains grew larger over the following few million years, on the slow march toward your own species, they didn't just get bigger, they got more organized, more specialized internally, with different regions taking on different jobs. And that same rightward lean that began as a small, practical habit while walking upright got picked up by the expanding brain and locked into place. Not invented by the brain, inherited by it, hardened by it. What started as a useful workaround for two newly freed hands became a wired-in, population-wide trait passed down through every single generation since, all the way down to you, sitting wherever you're sitting right now. Two completely different evolutionary pressures, separated by millions of years. Both required, in that exact order, to produce the hand you're holding that pen with right now. And here's a detail that should genuinely give you chills. The researchers ran their model backward across the fossil record to predict handedness in extinct species nobody has ever been able to test directly. One species stood out immediately. A tiny, small-brained relative of ours nicknamed the hobbit, found on the island of Flores in Indonesia. According to the model, that species should show a much weaker handedness bias than modern humans. Why? Because the hobbit had a small brain and its body was built for a mix of upright walking and tree climbing, not full, committed bipedalism. It's missing both ingredients. And the model predicted exactly that before anyone confirmed it. When a theory predicts the gap in its own evidence before you even go looking for it, that's not a guess anymore. That's a theory earning its place. Stop and notice what just happened. A question that sat unanswered for decades, across multiple scientific careers, got solved by adding two variables nobody had thought to combine before. Not a new fossil, not new DNA, just the right two ingredients, mixed together for the first time. So now you might be wondering something else entirely. If being right-handed is this strongly favored by evolution, why does anyone end up left-handed at all? Wouldn't natural selection have erased that trait by now, generation after generation, until everyone matched? Here's the answer, and it's stranger than you'd expect. Being a small minority might actually be the advantage. In any physical confrontation, predictability is a weakness. If almost every opponent you'll ever face is right-handed, your brain quietly learns to expect attacks from that side, the angles, the timing, the footwork. A left-handed opponent breaks that expectation instantly. Watch any combat sport closely, and you'll notice it. Boxers and fencers who lead with their left hand are often described as awkward to face, not because they're stronger, but because almost nobody trains against that mirror image often enough to feel comfortable. Some researchers believe this is exactly why left-handedness has never disappeared, despite millions of years of pressure toward the right. There's a real edge to being rare, as long as you don't become too common to stay surprising. If left-handedness ever became the majority, that advantage would vanish overnight, which may be part of why it has stayed locked around 10% for so long instead of climbing or vanishing entirely. Which means the 1 in 10 people who are left-handed aren't an evolutionary leftover. Some kind of mistake evolution forgot to clean up. They're a deliberately preserved exception, kept alive by the exact same competitive logic that made everyone else right-handed in the first place. The same evolutionary pressure produced both outcomes at once. Think about that the next time you reach for a coffee cup, or sign your name, or throw a ball without a second of conscious thought. None of that started with you. It didn't start with your parents, or their parents, or anyone in living memory. It started with an ancestor who stood upright for the first time, millions of years before language, before fire, before anything you'd recognize as human, and discovered that two free hands work best when they stop being identical. Every signature you've ever written carries that decision forward. Every time you hand someone an object without thinking about which hand to use, you're not making a choice. You're finishing one. A choice your body made for you before you were born, that your distant ancestors' bodies were making for them, long before either of you existed to notice. So go ahead. Pick up that pen again. It already knew which hand you'd use. It's known for millions of years.